Welcome back, Algebrists. Today is Monday, October 27th, and the good news for you guys is that I'm pretty sure that next Monday I will be bringing donuts to everybody. It's my guess, purely because of our snow bet. Real quick, anybody in here allergic to anything? Like you have gluten intolerance, you have chocolate, anything that you're allergic to that I need to be aware of before I bring 24 donuts into the classroom? Do they make caramel donuts? Isn't it maple? I don't know. I'm just gonna buy the ones that are the longs is what I will buy. I'll buy like 24 of those. If you win, I'll take suggestions. Like I'm not gonna go and pick out 24 different donuts, but cool. All right. So if it looks like it's going to snow as I check the forecast, we'll jump in. So last class we had like a 5-minute intro to this. And in 2.7, we were looking at non-linear inequations. Whoa, non-linear systems. Weird. So, okay. Now, I'm going to keep this here real quick. Check it out. If we say we have a linear system, you don't need to change yours. This is just a nice language thing. If we have a linear system, it implies that I have two linear equations. We're just looking for where two different lines cross. If it's nonlinear, all that means is at least one of them must not be linear. Now, when we titled this last class, and you don't have to change yours, we called it linear quadratic. One of them is linear, the other one is non-linear. So the same language works. I'm okay with that. And you wrote linear dash quadratic, right? Nope, you do not have to replace it. A nonlinear system just has one that's at least one that's not linear. We still have it. You have a more specific detail than mine. Cool. Linear quadratic systems are what we're looking at. Now, the only thing I believe that we did last class is we said, hey, if you give me a line and a quadratic, there's 3 ways that these guys can meet, right? So what was our first bullet point? Did we have one? Intersections. Okay, and I'm just catching up to you guys. So with intersections, there are only 3 possibilities. What's one possibility? One intersect between them. So here's a lovely quadratic, and I could draw one single line that just touches it right here. This is one intersection. Okay, give me another possibility. It could be 2. What should that look like? In the middle. What do you mean by that? So it could be a horizontal line like this. Could it also be a slanted line like this? Yeah, like there's a whole bunch of possibilities, but I can very clearly see that there are 2 points of intersection here and the last one. How would you draw it with none? So I would be careful about using a vertical line only because their slopes are weird. But this system right here, are they ever going to cross? No. So I can see that, all right, we have a possibility of 1, 2, or 0 intersections. Is that the last thing that we did? Okay, so let's go ahead and knock it out. If you need to step out, I'm okay with that. We had one example. What was its name? Solve system. Now, we could word this a bunch of different ways, right? I could say find where these 2 intersect. That's a way that we could justify it. And we had A, I assume. And hook it up. What is our system of inequality or equations? Okay. All right, so here's where we jumped in and we didn't really start it, or did we? All right, so as we're looking at these, algebraically, we could present this a different way, and we'll see a couple different presentations for these. But remind me when we did systems of equations like last chapter, what are the 2 approaches that we've seen? Substitution and elimination. Now, the same methods are going to apply with these. Now, I don't really have a strong preference to which one that I use here. I'll tell you, my gut would say to use substitution. That's what I would naturally want to use. If we are using substitution, there's 2 routes. We could notice that this is already solved for y. Could I just take this top equation and plug it in right here? Now, we could manipulate it first to make it look a little bit nicer if you'd like. What I mean by that is just to make the work look a little bit more natural, could we solve this one for y? I'm going to add a y and subtract a 5. I think that we could get 2x minus 5. Now, I did 2 steps in one there. Notice, at this point, if we commit to this direction, this is equal to y, and this is equal to y. And this feels like a trick question, but I promise it's not. But without any of this in mind, can you tell me for certain what y is equal to? Itself. Like, you're right that it's 2x minus 5 here, but just in general, y is equal to y. And I just happen to have y written 2 different ways. Since we have y and y, what do you think we should do with these? Set them equal. Now, we really are substituting, right? I'm just, instead of plugging it into the middle of this expression, I'm simply going to say, hey, here's y. Let's plug this in and just see where it takes us. So here we go. I now have 2x minus 5 is exactly equal to 3x squared plus 3x minus 5. And I will annotate here. All we have done is substituted. Substitute. Okay, at this point, here I am, and it's embarrassing. It's Monday morning. I'm super tired. I'm in a terrible mood. You can probably tell just how bad of a mood I'm in right now. That was a joke, just for the record. Hopefully you guys don't really get that vibe. What do I set an equation equal to, especially a quadratic, if I'm trying to solve it? 0. Okay, can I make this equal to 0 in one line? What would you have me add to both sides of this equation? So I'm going to subtract 2x and add 5. Now, I'm going to write both of these in one line. We'll do minus 2x here, and I'll just make sure it matches underneath the correct term on the other side. And to undo this one, we'll do what? Plus 5, and I'll write it under the plus 5 here. And let's just see what shakes out. On the left side, what remains? 0. That's a good sign, because that's what we set it equal to when we're solving. Over here, we get a 3x squared plus x, and that's it. Now, we are trying to solve this, and we have a plethora of choices. Plethora just meaning many of them, right? If you didn't know that, plethora just means a lot. Okay, could we quadratic formula? I mean, we could. What's A? What's B? And trick question here, kind of. What's C? 0. Do you really want to go through the process of negative b plus or minus the square root of b squared minus 4ac all over 2a for this? No. Could you? Yes, and you would get the right answer, but remember, part of your goal should be the right answer, of course, but the other part should be not wasting time and being efficient when possible. So, quadratic formula, I will always recommend, is our last option if everything else fails. Never jump right to it. You're going to wind up wasting a ton of time. So here we are. We need to solve this. What's the F word that we can use to solve these? Factor. What's the first stop along our factoring pathway? Greatest common factor, says Ronaldo. Is there a GCF that goes into 3x squared and x? X. Now, more than just 1, right? Because it's not just 1 as a number, it's x. If I factored an x out of this, what stays behind? 3x? Is it plus 0? Plus 1. Okay, when we do this, this problem feels incredibly simple, I hope, once we get here. I have this thing now written as a product of 2 different, what are these now? They are my factors. Now, I know that this times this is equal to 0, which means we get to employ our 0 product property immediately. Here we go. Here's one factor. Here's the other factor. What value of x makes this factor equal to 0? So it feels like a trick question, but if x equals -1, does this become a 0? Like, this is always a weird question. This is it. Just set this factor, which is just x, right, equal to 0, and we don't have anything else to do. It's a weird question to ask. This one will have a little bit more work. We take this second factor, 3x plus 1, and we want to set it equal to what number? 0. I want you guys to spend like 10 seconds, get me the value of x there, and check with your neighbor once you have it. One step away there, Kyle. Solve that second factor, that second equation that we just wrote, for x. So I'm going to subtract this, 3x equals -1, and then divide both sides by 3. And I think that I get my other solution at -1/3. Now, for this, remember what it is that we're actually looking for with the system. Did anybody get something other than x equals -1/3? Now, we are looking at a system of equations right now, and we're trying to find where the what happens with their graphs. The intersect, or the multiple intersections. Right now, all I know is the x values. Could I get the y values? So rephrasing that, just for the record, that's a yes or no question, which I should not ask. How do I get the y values that associate with each of these? Plug it in. What do you mean? Plug it in where? I can plug it into this equation right here, or this one, or any equivalent form, which this one seems particularly useful if all I need is a y value. Now, every book does this a little bit differently. I'm going to make a little note here as I come up this way, and we'll just say, now, find, oh, this is super weird, the y values. And I'm going to rewrite my x's here, but I'm going to do this in a very particular way. So if you happen to be trying to zone out right now, I'm going to tell you don't for like the next 30 seconds. Bless you. I'm going to rewrite the two x values that I found, 0 and -1/3. And I have no issue, and I don't think you guys will either. Can we use this equation right here to solve for y? Okay, so plugging that in to y, I'm going to do a little bit of scratch work underneath, but let's just see. The first x I'm going to plug in, based on the way that I've written it, is what? So if we do 2 times 0, I'm doing this one, minus 5, what do we get for the y value? -5. So check it out. One of our points of intersection happen at 0 and -5. That's x and y. We're going to rewrite these as an ordered pair in just a moment, but I want you to now plug in -1/3 and get me the other y value that associates here. I'm going to pause it. I'll give you guys like 30 seconds. Find me the other y value that goes with this x at -1/3. Okay, so maybe we'll check. I'm going to use which x value in this expression? -1/3 minus 5, right? Okay, so we'll just do 2 little steps and I'll work downward. Any objections to me just saying -2/3? Okay, so now we need to do -2/3 minus 5. And it's really over 1. I'm cool with that. What's my clever choice of 1 that I'm going to use to make my common denominator? 3/3 says Mark. Can I get a second on that? Okay. So it looks like -2/3 minus 15/3. And I don't think I need to do any more work here. What is the associated y value? -17/3. Okay. Is there a way that we could be 100% certain that we are correct? Plug it in to which of these? Both. More than either. Like certainly either will work and should work. I'm going to actually check mine on the graph here in a second using Desmos. And do you guys use Desmos at home? I would encourage you to. It's super duper helpful. For this, we're going to check, and I'm going to write my answer. Let's see here. We have 3x squared plus 3x minus 5. We'll go over to Desmos. 3x squared plus 3x minus 5. And the other equation? 2x minus 5. Okay, so as I look at this, if I zoom in, are there indeed 2 places where they intersect? So we're checking real quick. I should find, theoretically, that it's at 0 and -1/3. So let's check. Is this intersection right here at 0 when x equals 0? And what do we get for the y value on our work? Hey, that's exactly the ordered pair that I see when I look at the graph. And this one should be -0.333, right? -1/3 and 17/3, and a little bit of like checking for division stuff. -17/3 definitely is -5 2/3. Do we have the correct values? So very last little part of this, how should we actually write our answer? 2 ordered pairs. One of them is at 0, -5. And the other one? Boom. We have found our 2 points of intersection for this graph without ever having to really deal with the process of graphing this thing. Problems like these feel okay, feel awful. All right, can I get everybody to give me some sort of thumbs up that says awesome, thumbs down says absolutely awful, anywhere in between? Okay, here's the deal. I'm going to give us one more, and we're going to check it. I'm going to have you try one. It is super important. If you are struggling here, what do you think is your best course of action at this point in time? Ask. You can ask your neighbors if you want. You can certainly ask me always. Cool. Let's try one more, and we'll do example B. And bear with me for one moment. Okay, I want you guys to go ahead and solve this system of equations with the understanding, again, I just want to stress, if you are struggling with it, it's okay. This stuff isn't super easy. Let me know. I will be coming around, but I want to hear theoretically controlled chaos. You guys can talk about these as much as you want. Cool. Did we all start by just setting them equal? Okay, I'm going to skip one little line here, and you guys tell me if this is what you get. After like 2 steps into this problem, I think we wind up with 0 is equal to 2x squared minus 10x minus 6. Okay, now if you're looking at this going, I didn't get that, I'll show that pre-intermediate step, I suppose. When they're both equal to y, we just set them equal. And then all I've done is I've added 2 to each side, gets me to negative 6, and I've subtracted 4x to get to that negative 10x. Okay, once we're here, automatically, we're just going to start solving using our F word, which again, one more time, it's not FOIL, it's factor. So let's run through the list. What's the first thing we always check? GCF. Is there a GCF? Okay, so there's a 2. What would stay behind if it's a 2 were factored out of all 3 of these? Minus 3. Now, at this point, we have the 2. If we wanted to divide both sides by the same number, is that allowed in algebra? Yeah, if I divided both sides by 2, and it's an option if you want to, I wouldn't normally do this, but this is allowed, right? I've done the same thing. What happens with this 2 dividing by this 2? They're gone, and the expression is simpler. Now, if you don't want to go through that process, it's okay. We don't have to. It's just an option. I can't factor this down anymore if we elect to keep it. So we need to look at this lovely piece. Is there any more GCF? Is it a binomial? No, it's a trinomial. Do you know the square root of this term? Do you know the square root of this term? Bummer. So it's not a perfect square trinomial. What's the leading coefficient? If I do this and I multiply 1 and negative 3, I get negative 3. Can we find factors of negative 3 that add up to negative 5? Bummer. So problem's broken. We fail, right? We just can't do it? No. How on earth do we go through this if we cannot factor with grouping, which shortcut is grouping? We can't factor this that way. Oh, my quadratic formula. Now, anybody feeling particularly theatrical this morning and want to sing to me the quadratic formula? Because I just can't remember it. Okay, anybody want to say the quadratic formula for me? Negative b plus or minus b squared minus 4ac all over 2a. All right, fantastic. Yes, sir. You could, and you could absolutely complete the square to solve this problem. But the benefit of the quadratic formula is that it's just what happens when we complete the square. So we're doing that in a much more direct route. If you would rather do that by adding a clever choice to whatever side, I'm cool with that. Okay, so in here, help me plug it in. What is A? What is B? What is C? What's A? 1, because 1x squared. What is B? Negative 5. Love it. And C? Negative 3. So here we are. Let's try it. X equals negative b would become what if it's negative 5 already? So positive 5 plus or minus. Now, if you're going to do this with a calculator, parentheses are the most important thing that you're going to type on your calculator when you're doing this. I'm going to just try to think it out without ever touching a calculator. What's -5 squared, or -5 times -5? 25 minus 4 times a is 1 and c is -3. All of this gets divided by 2a. 2 times 1 is just 2. I saw a hand pop up over there in my peripheral. No? Okay. So let's clean it up a little bit more. I'm going to work this way just so I can keep seeing my answers. X equals 5 plus or minus. Gosh, does the thing that we're taking the square root of have a name? The discriminant. So here we go. 25 minus a -12. 37 minus the negative. And that's these parentheses, super duper important. If you don't have them, you might miss that. All over 2 still. Now, in this situation, how many answers do we have written on the board right now? There's really and truly 2 of them. If you stop here, I am completely cool with it. If we were going to check, say, on a calculator, is our calculator going to tell us this? No, even Desmos won't tell us this. For somebody out there who doesn't see the 2 answers, help me break this into 2 different pieces. What's one of the answers? So I would say 5, but I agree with you, Liam. 5 plus root 37 over 2. And what's the other one? 5 minus the square root of 37 over 2. Now, in doing this, our answer is the y values are going to be super ugly, just a heads up. Would it be reasonable at this point to actually give us the approximations instead of the exact answer? So there's always a fine line between should we or shouldn't we. In this situation, I do think it's reasonable to do it just because the numbers are so ugly. I would probably do it as the exact answer first without ever changing anything and then change it after the fact. But if we wanted to, let's approximate this. And I'm going to grab my calculator, but if somebody would second me, that would be awesome. 5 plus the square root of 37. Lost my spot. I should probably hit the right button. 5 plus the square root of 37. And we're dividing it by 2. Can somebody confirm approximately 5.54? Okay. And then just a pro tip, if anybody is using these calculators, when we're here, and holy cow, it's super dark on my screen. When I'm here, notice I just had 5 plus root 37. You can just scroll up if you want and do this. We'll just change it to a minus. I'll hit enter and then divide it by 2. And I think that we should get negative 0.54. Negative 0.54. Okay, are we done? What am I wrong? Okay. So it could still be here. And now we're solving just this part of it because this 2 doesn't matter. And here's the reason why. I didn't physically divide it out, but check this out. Right now, I think I have 2 factors. They're not quite prime. Does this factor any further? So even if we keep it, if I tried to set that equal to 0, does it have an x in it? Is there any value of x that's ever going to make this be a 0? No, 2 is always equal to what? 2. Whether we write it there or not, the only part that could possibly be 0 is this guy. So that's the only thing that we're dealing with. Great question, because it does look like it just magically disappeared. It didn't disappear. We're just ignoring it because it can't ever be 0. Cool. Or if you hate that answer, yeah, we divide it by 2. Cool. All right. Now, once we get these, we're not quite done. How come? We need to find the y values. So using a calculator, I think that this seems like a pretty easy spot to plug it in to get the y values. Let's get it. If these are my x approximates, my y approximates, 2 times 4 times 5.54 is what, 22.16? I think it's 22.16 when I subtract it. Somebody check me, though. When I subtracted 2. Or is it 20.16? So we're all putting a lot of trust in Naomi. I'm going to double check here. 4 times 5.54 minus 2. Say it again. 20.16. Okay, my bad. And when I do negative 0.54, and I'll just do the same thing, 4 times negative 0.54, and I suppose I'll actually be able to type into my calculator. What do you guys come up with? 18? Negative 4.16? Good, that's what I heard. Okay, we are so close. We'll check this on the calculator since the approximations are going to show up on the calculator or on Desmos. How should I write my answer, though? 2 ordered pairs. What's the first one? 5.54. And as long as we do things in order and stay consistent, it should be 20.16 that associates with that. And the other one? 54 and negative 4.16. Okay. I'm sorry? So we don't have to, and that was Michael's question. You could have solved here if you wanted to add something to both sides of the equation by completing the square and doing all that, you can. But remember, the quadratic formula is there so that we don't have to complete the square over and over and over, because it naturally happens. So I'll come dig through yours, or I'll show it again completing the square, and we'll see, because you did it that way. Okay, so bear with me. Angel will come over there. And I'm just going to check here. 2x squared minus 6x minus 8. Michael. We're going to get the same answers regardless. So I'm okay with either. Because even if you complete the square, you're going to get this ugly answer. And then you would approximate it. Yep. I will not be able to tell. I mean, obviously your work will show. But let's graph this other one. We'll turn off the blue one. All right. We said that there were 2 intersections. Does it look like there's going to be 2? And confirm for me, is one of them this point? 5.54 and 20.16. And the other one looks like it's here, negative 0.54 and 4.16, negative 4.16. All right. These problems, we're starting to put together like all the pieces. Everybody agree that these are kind of lengthy and not the easiest thing we've done. So I think that we should debrief. No. Should I have? All right. So, couple things here, just so you guys kind of know where we're going. This is the very last section of chapter 2. Now, I don't think that all of this stuff is enough of a review that we could just blast through the practice test tomorrow and take the test on Wednesday. I don't think that's a great idea. So what I'm aiming for, and travelers, anybody who's leaving for whatever reason, I already have this done. We are going to finish this section tomorrow and use some time in class to get some practice with stuff. And then on Wednesday, I have a practice test this time that is not just a traditional team test, but it's a little bit longer because there's a lot of stuff in this chapter, a lot of really, really important ideas. What I will give you guys on Wednesday. So tomorrow we'll come in, we'll finish this section, and then we'll start looking at the homework and stuff. We'll have time to ask questions. But just so you guys can see kind of what it looks like and what it'll feel like, I'm going to give you an assignment over the super long weekend. Just a heads up. The assignment over the super long weekend is your practice test. We will come back together Monday after and look at everything. Now, as we go through, and I don't see it on this computer, so it's going to be on the other one. That's my bad. Or pause. It's probably on my desktop.